Let me know if you see it. You should see, let's actually shield the Recon Pro website. Let me know when you see it.
We see it.
Awesome. So today we'll talk about the first 2 trophies from Recon, 2 bugs that I found in the Tapioca contest through Recon Pro. And the reason why I'm such a fan of my own product is that I'm going to talk about kind of the lifestyle of using the fuzzer to find bugs. And so the main, the main meat and potatoes of our chat are going to be tied to these 2 findings from the Tapioca contest. Number 69, tied to an incorrect decoding, and number 55, which is tied to a possibly irrevocable denial of service due to a overflow and a specific check. And so there's multiple aspects to this, and over time I'm learning about red teaming versus blue teaming, which is the idea of red teaming, meaning we find attacks, we want to break stuff, and blue team, we want to defend. And so I'm going to try to give both perspectives of these findings. But fundamentally, the main idea around encoding and decoding is something that we spoke about in our other office hours. And I'm going to share the Miro board in the comments, so feel free to join me and check it directly. But fundamentally, anytime you have some sort of a encoding, some sort of a operations, some sort of a library, fundamentally, you have an amazing opportunity to encapsulate that logic and to encapsulate those tests. So this is something really important when you're on the blue side, as in you're building your own project. We talk about this idea in the invariant-driven development, but fundamentally, the key idea here is that if you can test something in a unitary way by testing it directly in the library, then that's going to be a lot easier than if you need to test it, like testing a function that calls the library and then does some stuff and then calls the library again. If you have to test this function, now you have a lot more overhead in terms of the setup, the configuration, the inputs, the things that can go wrong that you have to test. And so anytime you have the luxury of encapsulating your logic into a library, that's what you want to do. And so on the blue side, that's really the key idea, is that anytime you have a library, and this applies to every library possible. And the reason why I say this was that as I was finding this bug, we were working with Centrifuge, and so shout out to Jerome. But fundamentally, that's the same idea, is that anytime you have some sort of an encoding, a message parsing, or a message processing library, you want to give yourself the favor of testing it at that level. And so I'm going to show the 2 ideas, which are 2 key ideas on how I tested these library. So I'm going to go on this omnichain libfuzz repository, which obviously is a private repository. And that's because that's kind of my workflow. So to kind of bring you back to the contest setup, my workflow will look a little something like this, where I'm looking at the code. I should have a bunch of MD files here. As you can see, like I have a ton of notes. Maybe I'll even make 1 MD file per file, and I write my own notes to prepare a report, prepare a bunch of stuff, etc. And then once I know I want to go deeper, I want to hit a specific area, then what I will do in the case of this library is I literally spin up a new template from Recon, which we shown a million times. But basically, you go on Recon, you either grab your template here on the build your handlers, or you go on create Chimera app, and we have a Recon compatible template that you can reuse at any time. And the fundamental idea is that when I'm dealing with a library, I don't need the entire code. And so you can see how instead of trying to make 200 files Foundry project compile, the first thing I'll do for a library is I'll just take it out and fix the imports and make it work locally. And so maybe there's some Open Zeppelin stuff, but fundamentally the only diff from the proper implementation is that maybe I'll have some relative imports, and then I'll just grab everything as is, and I'm then going to instrumentalize it, which means that if every function is internal, I'll basically make a simple tester to make it so that it no longer is internal. And in this case, I think I almost skipped that. I basically just grabbed each library and I just inlined it. And the key idea of a library of this type, which is an encoding decoding library, is that you need to have a level of idempotency. And so a bug, first of all, when did I do this? You can see it from my comment here. It's just when you don't get it, just fuzz it. So I didn't spend hours trying to understand the library. What I did is I quickly scaffolded this to have the fuzzer think for me and basically give me some ideas in terms of low-hanging fruits. And so in this case, I basically instrumentalized each function. You can see I just go through the list of every internal function from the library, and then I basically just check every value and I compare it. And what I found was this was downgraded to a documentation error, but basically I found what I believed at the time was an encoding error in the compose message library, simply because calling the official encode message actually breaks the encoding. And so I did report this as high and it was disputed. But that was when I saw that gave me a clear idea that there could have been something in the library. And then I just went and did this idea of grabbing all the parameters. As you can see, I have all of the parameters as inputs for my public function that will be called by Echidna. And then I just encode, and then I redecode, and then I compare that the values do match. And that's basically all there is to this idea. Every time you have a library, you just go on the in and the out, and that way you just compare that whatever was passed, so we would call it, I guess, the A and the B, they must match at all times. And that's how you get the most basic encoding errors, or you get implementation errors. So that's the first level of fuzzing for libraries. And after a while, I realized that this is not necessarily the best usage, and that's because most projects will pass in the encoded data to some sort of a messenger contract, and then they will have to decode the data somewhere else. And so in order to test that, I used what I call the malformed target functions, which is basically doing the opposite direction. So instead of encoding stuff, I just pass random bytes. You can see that the input is just bytes, and I decode those bytes to grab the value, and then I re-encode it to verify that the decoded value will re-encode to the same bytes, because otherwise either there's an issue in the decoding, or it means that these bytes, or it means that different bytes can match the same decoded output. And that's typically due to using encode packed or custom packing, which is actually how I found this finding. So fundamentally, this finding could be found visually as well. And I think I definitely was looking there, simply because if you do a quick check here, you'll see that here we have MBI encode packed. You'll see that we have encode packed here. And what you see as the main difference in this function that doesn't have any issue versus this function is the usage of message.length. And so fundamentally, that means that the duration, which uses duration offset, and user that uses the user offset will always be looking at the same bytes. Whereas the amount, as you can see, is using this message.length minus the duration offset. And so it's fundamentally, let's say we have user, so user will always be in the bytes representation there, duration will always be here, but amount could actually be in a dynamic range, which is equal to message.length minus duration offset. And so that means that given this value, there is actually an infinite amount of bytes that encode into the same bytes. And so the encoding is actually non-ambiguous because the encode function will always encode via ABI encode packed, but the decoding is actually ambiguous, which means that there are many types of bytes that will map out to the same value. And so once you, the only way to find that is to fuzz in the opposite direction by passing the random bytes. And if you do that, I think within a few seconds, you should be able to find that result. You can see that as I was doing this, I wrote my own initial notes on how to do it. And then I set up a jobs, and that's what I do when I don't want to share the result. I guess this one broke, so I guess it didn't make it. But then when I ended up doing the submission, I basically ended up finding a random sequence for which that was the case. And so once you have instrumentalized the tests and you have your repro case, then you basically have already done all of the work. And so this is an example of something that on the red team, as in bug bounties, should actually not be that common. I don't think, I think you would consider this the most base type of bug. But on the blue team, on the defense, on building your own project, I think this type of tests have got to be like core tests. Like you should always do an encode decode on your library because it's so free to do, it's so simple, and at the same time it will prevent any possible issue that could be introduced by any form of implementation. And going back to our chat about modular invariant testing, again, you want to make every unit, every atom to be as simple as possible to test. And so if you commit to this idea of having the malformed versus the well-formed inputs, then you basically get effectively 100% coverage, because the only thing you're missing here will be external integration or the soundness of the values. But internally, on a more core level, you get a very high coverage for effectively a few minutes of work. And so this is a technique that is extremely low skill. The level of skill that takes for you to do this is basically zero. You copy the encode decode function on a Chimera starter. You put the test function to verify that it matches by asserting it, and then you run Medusa, and it literally takes you 10 minutes. And in 10 minutes, you can find a ton of low-hanging fruits. And on the blue side, in 10 minutes, you have made your library exponentially safer with close to zero work. And so if there's one test, I guess it's two, but if this one setup that I can recommend is always done through invariant tests, is gonna be the encode, clean input to decode and match, and the opposite direction, which will be the bytes decode into re-encode for the uniqueness. And so in the case of fixing this bug, by the way, you actually could keep the message.length here, but you would have to enforce that the bytes message has a specific length, because given the fact that you know that the data will be generated via ABI encode packed, we can do the math, and address will be 20 bytes, a duration is 96, so it will be, what is it, 12 bytes, and then the amount will be most likely UN256, so it will be 32 bytes. You just sum those up, and that's going to be the exact length of the bytes that you would expect on the decode function. And so additional check you can add, especially when you work with ABI encode packed, will be to ensure that that's the length of the data. Because otherwise, even if you had this duration offset removed and you add or rather if you add a amount offset instead of this message.length, then you could still have ambiguous bytes simply because you could append a ton of value to the bytes that will simply be ignored, which is actually something that technically Solidity already does. So it's something to keep in mind around how the apparently higher level functions actually interact with the lower level aspects of the EVM. But I think I've spent enough time on this. Let me know if you have any question. We do indeed have 20 bytes on an address. And so if you ABI encode it, it would actually occupy 32 bytes, a full word. But when you ABI encode packed, it would only occupy 20 bytes, which is the necessary length. And so to me, anytime I don't want to think, I'm going to always do this. There is no world in which I don't try this, simply because it's extremely low effort and the payoff can be very interesting, because sometimes you will find a direct bug, other times you're going to find preconditions, which actually leads us to the second bug. Because when I started, when me and Antonio started working on Recon in December, and December was gonna be our part-time month, and then we did full-time from January. But the main idea that I had back then was that I could just have the fuzzer write me an exploit, as in you basically make an assertion, and then you wait, I don't know, you wait a week or something, and then you basically get an exploit. And my current experience has been that this generally doesn't happen. As in, for a fuzzer to actually produce an exploit, either takes too long or generally is too specific and too accurate. Like you're asking it to do something that is a little too precise. And so what I've been very successful with recently is instead to use the fuzzer to give me a precondition to an exploit. And so this is something I'll talk about as more contest results come out. But fundamentally, you don't want to think about a entire exploit, because you can probably figure out how to set it up and you can probably figure out how to maximize it. But most of the time, the thing that you're unable to do as a human is getting the precondition or getting the inputs that will give you a precondition. So this will become very relevant soon. And that's because, if I can just, shield my own work, the main finding, which obviously was found by very clever warden, Ronnie, if I'm not mistaken. Yeah, Ronnie found it. But fundamentally, what Ronnie did is he basically wrote like a Python script to get him to do this. And then, he quote unquote, we can call it gaslighted or bullshitted his way to convince people, or just use some end-wavy math to convince the judge. Whereas what I did with the fuzzer is I asked the fuzzer to give me a sequence that will generate that specific input. And so the main difference here is that if nobody else found this bug, if you don't have this sequence, your bug is going to get disputed, because through this sequence you can actually reproduce the bug, whereas through some math you can just argue that the bug could happen, but you don't actually have demonstrated it necessarily, or you haven't made it as simple as possible. And so this is my my butthurt way of saying that my report is more detailed. But fundamentally, what I did is I saw this line, and then I looked at the code and I saw this comment, which, to be quite honest, I remember having seen this. And that's because I was also the previous reviewer at Spearbit for Tapioca. And so I remember not having enough time to look at these lines well enough. And so I was never sure if this line could ever be hit. And so what I did to save me time was I basically just put an assertion in this line to ask the fuzzer which I obviously put on the cloud through Recon so that I don't have to think about it. I just put the fuzzer and ask the fuzzer to find me a sequence that will hit this line. So if I go into my own implementation, we'll see that similarly, I yoinked the contracts and I simplified them a bit to have basically a transfer. I just put a tap token as in a ERC20 token, very simple token. And then the TW tap I simplified not to use permit, but I fundamentally didn't change it that much. And then I introduced a jackpot event, and I put the jackpot event exactly where I just said. And then as you can see, my audit tag is literally telling me if this happened, we found a crit, because I was unable from a cognitive perspective to imagine a scenario where you can actually get that to be 0. But I knew that if I can get this to be 0, then this line right here, magnitude greater than equal to pool cumulative times 4, will always revert, because you're trying to get something that is greater than 0, and everything will always be greater than 0, even 0, and so it will always revert. And so that's the logic around what I did, and hopefully that makes sense. So I'm seeing a question by Renzo. I see you have a raise instruct in your target function. Does Echidna? Yes, Echidna handles all of that. Just put them in a struct and it's okay. I always use, you don't have to use basic data types. Medusa and Echidna are amazing. You don't have to do that. So it works fine. And maybe the visualization is a bit clunky, but you will be fine. So definitely you can fuzz anything. And so the point that I'm really trying to drive home is how I had an idea of something, because I remember looking at this line and asking myself, when could this revert? And then I literally showed you in the comment that these were my notes. I'm like, this should be epoch.duration, right? Because obviously you should never decrease it by more. It should always be epoch.duration. And then the logic here was, basically I just looked at the math for compute magnitude to figure out how it will break. And the more interesting aspect, we'll see how it goes for me. But the interesting aspect about having done this, which I'll go back to in a moment, but is that once you have done something like that and you set up and instrumentalize your POC, then I was able, in maybe an hour from the, maybe let's say 2 hours from the start of the contest, to basically just alter the same POC, rerun the fuzzer in the cloud, and then send a new POC which is tied to the latest changes, simply because unfortunately there are millions of ways to cause DOS when you have multiplicative math, which is something that I generally don't recommend any project have. You should never have multiplicative math if you can avoid it, simply because it's too hard to think about. Whereas if you always have a segment type math where it's always clear where you are and you can't just multiply or divide back into other bounds, it becomes a bit easier, a bit safer to reason around it. But fundamentally, that was the idea. I had an idea. I couldn't write a POC for it. I had no idea how to get to that. And so I figured out what was the smallest, simplest precondition that the fuzzer could generate. And so I just put an assert false. I let it cook, and you can see how it will fundamentally participate. Then it participates again to lower the value. It warps to the end of the epoch so that you can unlock, and then it unlocks a position, which is one of the 2 positions. And so the there's a lot more that could be done here, and I wanted to look into this, but basically what I did that I was never able to find was I tried to fuzz for a way to cause the denial of service by only depositing and I was unable to do that. I've let the fuzzer run for a week just with the deposit function, just to generate that. I was never able to do that. Obviously, only through formal verification you will be able to prove that this is impossible, whereas maybe it is. But fundamentally, that's really the key modus operandi, is you figure out a precondition and then you fuzz for it, and then once you basically you let the fuzzer cook, and then the rest of the work you can still do manually, because you don't necessarily need the fuzzer to generate the entire sequence, but most of the time you will need the fuzzer to generate you the precondition. And so that's how I think about it. That's how I go about doing more complex type of POCs or exploits, is I will try and chain different fuzzing campaigns where I try and fuzz for a precondition, and then I try to chain it with another precondition so that I can eventually find something that mentally is too overwhelming to be able to handle. An example would be donation, rebases, multiple rebases, that type of stuff. That can be very complicated to keep in your head, whereas once you and obviously you could just write a formula and be done, but if you actually want the POC, the fuzzer is the best way to achieve that. And so this is kind of the idea, the two key ideas which I've explained in the past already, but fundamentally that's an example of actually using them. The first one is kind of a pattern. Anytime you have a library, that's what you want to do. You always want to do a test for encoding and decoding, and then for decoding and encoding. There's no reason not to. It's so easy. And then the other one is to instead use the fuzzer to specify a state that you need as a precondition for an exploit. And so this is the red side explanation of this. But now let's look at the blue side explanation of this. And so the blue side, which is something that we call doomsday invariants, will be that you as a developer on TWTAP, you basically would formulate this as something like, I can always deposit into TWTAP, or I can always deposit my tap into, into TWTAP. So that would be your blue side property. And then a way to test it will be that you will write something that looks a little like this. You will write something like, if tap greater than 0, then try twtap.lock. I don't remember the name. I think it was participate. So I'll call it participate. And then you will basically assert that, success. And so that's kind of the pseudocode of what you will do. And that's because as a protocol developer, you want to specify, your liveness properties, functions that should never be denial of service. And that's, I guess, the other side of the same coin, because as the red team, my goal is I want to get, overflow or 0 value, because that means that as the attacker, I will be able to participate myself, and then everybody else is excluded, so I gain against them. Whereas on the blue side, you will want to ensure that everybody can participate at all times. And so they are basically the same thing, they're just two sides of the same coin. And so your perspective changes a bit, but fundamentally, that's why it's so important that you think about what will be the scenarios that will keep you up at night, what will be the scenarios that you never want to happen, and you want to be very explicit about the functions that should never revert given specific conditions. Another example would be overflow. Perhaps you will want the withdraw function to always revert, but to never revert via overflow. And so that's the type of tests that are very well suited for invariant testing, because you set them up once, you set them up as part of your specification, and you never have to think about them again. But now forever, every time you make a change, every time your development process continues, changes, you have audit fixes or whatever, you always have those tests again. Whereas as the red side, you always have the attack again. And so anytime you figure out a new precondition, because I didn't think about the fact that, you know, the compute magnitude could be less than a week. And so if you set this to a week, this actually still causes denial of service in certain conditions when you have a very small cumulative. And so this type of logic is something that you basically refine, but fundamentally to go from version 1 of the idea to version 2, it's really just about iterating on the same tests, because you're ultimately just changing the specific assertion that you're making, and but all of the setup is the same, and so it actually ends up becoming extremely economical after you set it up. It's extremely uneconomical when you get started. It's very punishing. We have some of the people working at Recon with Lawrence and Nicanor. They can attest to the fact that, you know, spending a month setting up some template is actually really rough. But the insane aspect is that once you set it up, it's gonna work forever, and so it has an incredible impact. So that's it on the presentation side. Renzo, if you wanna link your repo here in the chat, I'll have a look. If you guys wanna send me some stuff to debug, I'm happy to check it. But fundamentally, that's the type of ideas you will see more and more from me, especially, is that I'm going to use the fuzzer to give me a certain precondition, and fundamentally my job as the, you know, hacker is basically to find the smallest precondition I need for me to be able to develop the full exploit, because the more preconditions you need and the more stuff you ask the fuzzer of, the more likely you are to, you know, for it to take forever and to basically be unsuccessful in your endeavor. We at Recon have the luxury of, you know, we can run a fuzzer for a month and we don't care. It doesn't change our lives at all. But at the same time, if you're working locally, you have to be very economical about the specific test that you check and the specific thing that you look for. And so it's really interesting how we're slowly zooming into the idea that invariant testing and fuzzing is fundamentally the declarative, it's basically a declarative work of asking the fuzzer what you need, but not what you need in the form of a full POC, but what you need in terms of a precondition. And so as the blue side, you will specify what you don't want. That's what you don't want. You have to enumerate everything you don't want to happen. Whereas on the red side, you basically specify the precondition that you want. That's really the main difference. That's also why blue side is so much more difficult. It's so much easier to break stuff than to build safe stuff, because you just have to specify one thing you need, whereas the blue side has to specify every possible scenario that you don't want it to happen. And that's why we advocate for having your bounds invariants, like some state global invariant that ultimately give you bounds for your behavior, so that you know that yes, the behavior in the middle can change, but you can never go past the bounds. And that's again because it basically is impossible to enumerate everything, whereas it's actually fairly easy to specify a hard limit of things that you don't want to see. So hopefully that helps you on the blue side. I think on the red side, it was a lot clearer, where you basically want to figure out the minimal property or assertion you need, and then you want to let the fuzzer do its job to get you the state that will break that assertion. Yeah, that's a good point by our Nemes. By the way, Renzo, if you want to send the code, Renzo, because I'm not gonna open my DMs right now, so send me the code here or will not look at it. But that's a great point by Arnemis, which is about gutting the code. That's what I call it. I call it gutting the code, which is basically you have to develop an intuition for what is the minimal code you need. And that's the only code you should test, because every additional check, if we go in our test here, like every additional check is a statistical delay on the actual sequence you need. Like you really want to think about this, because that's basically what you're doing. You are sacrificing your personal time to make the fuzzer time shorter, because every input you add is statistically is making it statistically less likely for you to find the sequence that you want. And so any input you remove is increasing the likelihood that you're going to find what you need. And so again, if you can always reduce and always summarize the precondition to the shortest possible precondition, you will be a lot more successful, because the fuzzer will take a lot less for it to produce an interesting sequence. And so but that's what I think is going to be the biggest change in the future, is that as we eradicate these these base stuff, because this stuff is not going to be here for a long time. There's no reason why every protocol developer doesn't fuzz, A to B, B to A. This is going to be a default for everybody very soon. But something that is not going to be a default will be simply chaining multiple of these preconditions, where maybe I check for a value being 0, another value being 0, and once I have this value being 0, I rerun my tester, but I started with a setup that gives me the 0, and then I enforce it that I never go past, I don't know, maybe 1,000, so it still maintains that bound, and then I want it to get the second variable to be 0, and so by doing that, I am removing all the need for this, and I'm just having the fuzzer focus on the next step. So if you do something like that, you can build a chain of preconditions that will make you find stuff that is basically impossible by hand. Obviously, some people are smarter than others, so some people will find bugs without needing to this at all. So my advice is always, if you don't need it, don't use it. But at least for me, when things get a bit overwhelming, I just ask the fuzzer the precondition I need, and it tends to deliver.